morning all. In today's lecture, let us discuss about varying and alternating currents. Okay, for MSc entrance exam preparation. Alright. So before going for the details, first let us go for the fundamentals such as DC. DC means direct current. So direct current means we can also call it as unidirectional current. Means this flows in one direction only. So the source for it is battery. Next AC. AC means alternating current. So here it changes its direction alternately. Changes its direction alternately. So only we call it as alternating current. So in such a way, once towards positive and other towards negative axis. Okay, plus y minus y. So in such a way, it changes its direction alternately. This we call it as positive half cycle of the AC, and this we call it as negative half cycle of the ACs. On x-axis we will take the phase difference or time period. On y-axis we will take voltage or current. Okay. So this we call it as negative half cycle. One positive half cycle and one negative half cycle gives one complete cycle. It gives one complete cycle. Right? And the source for this is transformer. Wherever transformer is present, AC is present. Wherever batteries are present, DC is present. Okay. So now let us see some of the symbolic representations. So one is battery. In such a way, positive line, negative line, battery. Okay, this is the symbol of AC. Now this is two parallel lines, the symbol of capacitor. The coil of wire, the symbol of inductor. Right? Now the symbol of resistor. In such a way. Okay. C, we call it as capacitance of capacitor. L, we call it as inductance of inductor. R, we call it as resistance of resistor. Right? Now these three components create opposition to the current. Opposition to the current. What is current? The flow of electrons. That we call it as current. Okay. It creates opposition to the current. Now see how resistor opposes the current. Let us see. Okay, how it is creating opposition. Now let this be the conducting wire. Okay, conducting wire. When current enters into the conducting wire, the atoms in the conducting wire starts vibrating from their mean position. Now these electrons, current means what? Electrons. These electrons collide with the atoms which are in vibration. So that collisions of electrons with the vibrating atoms in conducting wire creates resistance. So when current is more enough to oppose this opposition, then it flows through the circuit. So how the resistance is creating? Due to the collision of electrons with the vibrating atom in the conducting wire. Right? Now next, capacitor. So resistance is created to DC current. Okay. Now capacitor. So capacitor also creates opposition to the current. How it creates opposition? Capacitor means two parallel plates. Two parallel plates, metal plates arrangement, we call it as capacitor. What is the function of capacitor? It stores the charge. Right? What is the function of capacitor? It stores the charge. So whatever the current passing through the capacitor, first it stores that in it. So by storing process, capacitor will oppose the current. When sufficiently it stores the charge, the remaining charge it sends through the circuit. In such a way, depending upon the capacity of capacitor, it stores the incoming current, and remaining after it has completely stored, it has how much it want to store, it just send the current into the circuit. In such a way, capacitor opposes AC current, and okay, it opposes AC current. Now next one, inductor. Then how this inductor opposes the AC current? How the inductor opposes means, inductor means nothing but I said the coil of wire. So now when the inductor, the current passing through the inductor, when current passes through the inductor, an induced EMF is generated, and induced EMF is generated in the inductor. Right? An induced EMF is generated in the inductor, and the direction of this induced or back EMF is such that it opposes the incoming current. The direction of this induced or back EMF is in such a way that it opposes the original current or the incoming current. Okay? So in such a way, it opposes the current flowing through it. So it opposes AC. So the opposition created to the current in DC, we call it as resistance. The opposition created to the current DC, we call it as a resistance. Now next, similarly in the same manner, the opposition created to the current in AC through capacitor, we call it as capacitive reactance. Reactance means nothing but opposition itself only, and the value of capacitive reactance will be 1 by omega c, where omega is angular frequency 2 pi nu. Now similarly, the opposition created to the current AC by inductor, we call it as inductive reactance, and the value of inductive reactance is nothing but equivalent to omega L. The value of inductive reactance is nothing but equivalent to omega L. We write it as XL, and here we will write it as XC. Okay, we call it as inductive reactance. Alright, now opposition created to the AC current, opposition created to the AC current by the combination of these components such as LR, inductor resistor, CR, capacitor resistor, LCR, inductor, capacitor and resistor, we call it as impedance. We call it as impedance denoted by Z. Right? So either reactance or impedance or resistance, whatever the words we are using, that is nothing but a single meaning. They say that nothing but opposition created to the current. Created to current. Opposition created to the current. So depending upon the components we are using, the combination of these components we are using, we will use the term either resistance or reactance or impedance. Okay, so these components create opposition to the DC current, as well as these components, especially the inductor and capacitor, creates opposition to the AC current. Inductor and capacitor creates opposition to the AC currents. Right? Now next, let us see when these opposing components are connected in the circuit, how the growth and decay of current takes place in the combination of LR, CR and LCR. So today's lecture is based on this LR, CR and LCR. Another thing, is it necessary for connecting such opposition components in the circuit? If we don't connect this, the current may flow, maximum current will flow through the circuit. Even though we are connecting these opposing components in the circuit. Why we are connecting? Why we are connecting means, if we don't connect this resistor or capacitor or inductor either in DC or ACs, the high currents flows through the devices. So due to that high voltages or high currents, device may damage. In order to take care of that electrical or electronic devices, these opposing components have to be connected in the electric or electronic devices. That may be resistor, that may be a capacitor, that may be inductor. Depending upon the current, depending upon the device, you will take the combination and correct just to save your current devices. Right? So now let us enter into our topic, LR, CR, LCR circuits. So here I am explaining these circuits only in the entrance point of view. I am not going for any details of mathematical parts. Right? So first let us see the growth and decay of current in LR circuit. Now here I am drawing the circuit. I am taking resistor, then inductor in series and connected it to a switch. Connected it to a switch. Right? So now here 2 points are there. Let it be A and a battery. Let it be B. Right? Let the EMF of the external battery is E. EMF of external battery is E. First let us talk about the growth of current. Right? First let us talk about the growth of current. Okay? So now here first for growth of current, what I will do means, I will connect this inductor to the point B. I will connect inductor to the point B. Right? So connecting inductor this to the point B means what? Nothing but connecting the circuit to the battery. Nothing but connecting the circuit to the battery. So connecting the circuit to the battery means the current flows in the inductor. Okay. Now due to that flow of current, a back EMF is produced or generated in inductor. A back EMF is produced or generated in inductor. And the direction of that back EMF opposes the batteries or original EMF E. So the value of this back EMF is L di by dt. The value of this back EMF is L di by dt, where L is the inductance of inductor, di by dt is the rate of change of current. Okay. So now this back EMF produced opposes the original EMF E. So now the total EMF becomes E, as it is opposing minus L di by dt. Now according to Ohm's law, this total EMF, we know na what is Ohm's law, V equal to IR. So there is potential drop across this inductor. Using Ohm's law, this total potential drop will be equal to IR. The total EMF now in this LR circuit, inductor resistor circuit, is E minus L di by dt equal to R. After going for some mathematical calculations, we will get the total current as I equal to, the total current I equal to I naught 1 minus e to the power of minus R by L into T. Okay. So this is the current in circuit at any instant, current in LR circuit at any instant t. Alright. Now let us draw a graph between the time t and current I. So as we connect it to the battery, the current grows or increases in the circuit. So that growth we denote with this curve. This is, and this is the maximum current, and this is the growth of current. Growth of current. Now here let us define the growth of current. How we will define means, now let us put T equal to L by R in equation 1. What happens? I equal to I naught 1 minus e to the power of minus R by L into L by R, or that is equal to I naught 1 by e to the power of minus 1, L strikes off, I naught 1 minus 1 by e, that is equal to I naught e minus 1 by e. What is the value of e? 2.718 minus 1 by 2.718. After doing certain simplifications, we will get 0.63 I naught. Okay, 0.63 I naught. If I naught is the maximum current, then I has increased to 63% of maximum current. So in order to I to increase to 63% of maximum current, how much time it has taken? L by R seconds it has taken. How much time it has taken? It has taken L by R seconds. Okay. And now this time we call it as time constant. Now let us define what is time constant. The time constant of LR circuit, it is defined as the time in which the current grows to 63% of maximum current. The current grows to or increases to 63% of maximum current. That we define as time constant of LR circuit. Alright. Now, before going for decay, okay, so let us see the behavior of inductor. Two questions which may be useful for your entrance test. One is behavior of inductor. Yeah, fine. So now here in circuit what we did, we connected the inductor to the battery. What happens? Current grows through inductor, right? When current is flowing through inductor, what is happening? An induced EMF, that is minus L di by dt, is produced or generated in the inductor, right, or developed in the inductor. Why we kept minus? To indicate that this induced EMF opposes the direction of the current. Induced EMF opposes the direction of the current. So now, thus there is a resistance to the flow of current, can I say? Or there is a opposition or resistance to flow of current, through inductor. Means nothing but a potential drop. A potential drop is across the inductor, we can say, no? A potential drop is across the inductor. Now this potential drop decreases with time. Why it decreases with time? Means because the change in current decreases with increase of time, right? As time is increasing, current is flowing, time is increasing, but due to this opposition, di by dt is decreasing. So only potential drop is there, and that potential drop also decreases with the time, because di by dt decreases with the increase of time. Now at one particular position we will get a steady state. When steady state is reached, now the induced EMF as well as the potential drop becomes zero. So here what is happening? As time is increasing, di by dt is decreasing and potential drop is decreasing. It goes on decreases, and at one particular time a steady state is reached. So steady state means that particular state where induced EMF as well as potential drop becomes zero. Okay, so here the concept is, when current grows, as time increases current grows, but induced EMF is produced which opposes the flow of the current. Now that is nothing but a potential drop across the inductor we will find, but this potential drop decreases because di by dt decreases with increase of time. At one particular time we will get a steady state where induced EMF as well as potential drop both becomes zero. Now the resistance, these both become zero means nothing but the resistance to flow of current becomes zero. That's it, no? The resistance to flow of current becomes zero. Means current is not having any resistance. Current is not having any resistance means in steady state inductor is acting as short circuit. So in steady state inductor is acting as short circuit. Understood the concept? So here as time increases, the potential drop decreases, and at one particular state the induced EMF as well as potential drop both becomes zero. So there will be no resistance to the current flow. So resistance becomes zero. So a maximum current flows through the inductor. So in steady state position, inductor is said to behave like a short circuit, right? This is the behavior of inductor while current is growing in the circuit. Now before going for decay, let us discuss 2 points. One is about short circuit. Do you know what is short circuit? So we will just listen. No. When the shops burn, we will say fire attacks. We say short circuit, due to short circuit. Even some fire accidents due to short circuit, we will say. Okay. So even the person may die if short circuit is severe. Many disadvantages are there due to short circuit. So why this short circuit is so dangerous? First, what is short circuit? Why this short circuit is very dangerous? Let us discuss that. Actually, short circuit means, already here I said, no, the flow of current through electrical device when resistance is equal to 0, that we call it as short circuit. The flow of current through electrical device when resistance is equal to 0, that we call it as short circuit. So what happens if resistance is 0? Current will flow, no? We will get maximum current, no? Then what is the problem in that? You may think in such a way. What is the problem means, when resistance becomes 0, this current we call it as short circuit current. When resistance becomes 0, this short circuit current is some 100 or 1000 times greater than normal operating current. Normal operating current, the short circuit current is some 100 or 1000 times greater than normal operating current. Due to that, the devices will heat up. And they will damage. If this short circuit is more than the range, many accidents such as fire accidents, etc. Will take place. And high level short circuit value, do you know? High level short circuit value will be from 30 kiloampere to 200 kiloampere. This is some 100,000 times greater than the normal operating current. The high level short circuit current value will range between 30 kiloamp to 200 kiloamp. So devices will heat up, devices will damage, insulation will damage. Even this short circuit current will ionize the gas. Explosion will take place. Fire will take place. So this many danger things may happen due to the short circuit of current. Then how to avoid this short circuit? By using fuses. Okay, how we will reduce? By using fuses. Okay, we will reduce the short circuit current. Now let us go for another small topic. Do you know why tube lights will not glow immediately? So in your home you will have a bulb as well as tube light, no? Both you will have. But when you on the switch, bulb will glow immediately but tube light will not glow. Bulb will glow immediately but tube light will not glow. Why? Why means, in tube lights will you see, we call it as choke. That is nothing but inductor. In bulb we will find anything? No. We will not find all these things. Just a filament will be there. That filament opposes the current. Tungsten filament we will use, opposes the current, and that opposition creates or heats the filament and it glows, etc. Okay. Now let us talk about tube lights. a choke or inductor is present. When current flows through the inductor, what happens? Back EMF is produced, and this back EMF opposes the incoming current. The direction of back EMF is in such a way that it opposes the incoming current. So when current is more sufficient to oppose this back EMF, tube light glows. Until then, the tube light just glow off. You will see that, no? Immediately it will not glow. Just so when the current is more sufficient to overcome this back EMF produced by the inductor or generated in the inductor, then tube light completely glows. Until then, just you will see, no, glow off. So in such a way you will see. Alright. Now let us go for the decay of current in a large circuit. The decay of current in a large circuit. So decay of current means, let us once see the circuit, no? I will disconnect this from B and connect it to A. Means I disconnected the total circuit from the battery and connected to point A. Means what happens? Now there is no supplier of current or EMF. There is no supplier, no? Now slowly the current starts decreasing. Okay. Now here the total EMF, what it happens? Actually in starting what we wrote, E minus L di by dt is equal to Ri we wrote, no? Now I disconnected this. So minus L di by dt equal to Ri becomes the total current. Now after doing certain mathematical calculations, the decay of current formula comes out to be I equal to I naught e to the power of minus R by L into T. Now as usual, the graph will be from maximum current. This side we will have current time. It is decaying. Now see, the graph didn't touch the x-axis. Means it is not becoming zero. It is not becoming zero. Why it is not becoming zero? Because inductor opposes the decay of current. Inductor opposes the decay of current. Right? Now I will substitute T equal to L by R seconds. So R, L, I naught e to the power of minus 1, I naught by E, I naught by 2.718. So I equal to 0.37 I naught. Means current is not becoming zero. It is reducing only up to 37% from maximum current. This we call it as time constant during decay. So during decay of current in a large circuit, the time constant is defined as the time taken, that is L by R seconds, the time taken by the current to decay to 37% from maximum current. We call it as time constant. So this is about a large circuit. Now similarly, in our next lecture, let us go for CR circuit and LCR circuit. Thank you. Stay with my channel Reshma Physics. If you like this, share it, subscribe it. Thank you.